it's time to take our buildings off ventilators. Over the last 18 months, we've become familiar with a new mechanical device under very unfortunate circumstances, the mechanical ventilator, which most of us associate with COVID, of course, and it can, in some cases, be a lifesaver. I wanted to talk about a different kind of ventilator that our buildings have actually been on for the best part of 60 or 70 years, which is not long in human history, since the end of the Second World War primarily. And that particular kind of artificial ventilation is air conditioning. We're aware of some of the costs of air conditioning, but not all. And this is a summary of some of the more significant ones. First, although not necessarily in order of importance, would be risks to health, which are becoming clear. They've been evident even before COVID, that allergens and pathogens were being spread, in some cases very serious ones, such as Legionnaires, by the recycling of air and by less than well-maintained air conditioning duct systems that collect dust and other mites, etc. The economic cost is enormous, and as I'll explain in a moment, is likely to begin to fall disproportionately on those who can ill afford it in parts of the world where the GDP is at its lowest. But the trend is that they want what the first world has got, and the price for that is going to be disproportionately expensive for all of us. And then finally, and perhaps most importantly, the impact on the environment, the environmental cost of air conditioning, which is likely to quadruple in the next 2 decades, which is frightening. And that will be converted. The energy use will be quadrupled, but that will also be contributing massive increases to greenhouse gas emissions, as well as locally heat island effects within cities. So the health costs, very briefly then, the biggest risk is this particular type of air conditioning. Any system that recirculates air, though, is a potential risk to health. Recycling dust, pathogens, and in this case, the split air conditioning is really just taking air from within the space, cooling it, and then pumping it back. So you can imagine if there's anything dangerous in the air, this is just spreading it around. And the last thing that you want to be doing, regardless of COVID, right? There are going to be other things in the air. Air conditioned lung is a medically recognized condition. And that has been around, as I said, long before COVID, but it's being given new attention with the advent of COVID. But respiratory problems, which of course are central to COVID, have been an issue with air conditioning for decades. But as I said, now recycling-based air conditioning systems are becoming under suspect. They're being scrutinized for potentially, there are some cases in China, for example, where it was fairly clear that the room air conditioning was spreading the virus. So the economic cost of air conditioning is going to increase exponentially in the next 30 years, but it's going to be disproportionately in the what most of us would consider now to be the third world. It may not be by the middle of the century, of course, but if you look at the areas where the biggest increases and the biggest proportions are going to be China, India, Brazil, those kinds of economies where, as I said, the GDP is among the lower in the world, and the contribution to the first world is still going to go up, but marginally relative to what's going to happen in in the third world. And if we look at the impact of that, the per capita consumption of electricity then is going to jump in those areas. Here's India, Brazil, Indonesia, Middle East, compared to China, compared to Western Europe, North America, then the per capita cost is, which is in the red triangle, or the red square rather, is going to jump by many times than in most cases in those economies where people are least equipped to be able to cover that additional hit to their income. And so, you know, it's going to be areas of the world like this that are going to be carrying the economic burden of air conditioning. You know, that increase in electrical consumption, somebody's got to pay for it, and it'll be individuals in these kinds of societies then. Environmental costs then, these are the contributions of CO2 or to CO2 emissions, okay, from 5 years ago and in 2050. So you can see huge increases in countries like Mexico, India, Brazil, China, less so in other countries, but still. So many of these statistics come from this document published by the Rocky Mountain Institute 3 years ago. And they were so concerned that they organized a competition to, well, as the title says, to solve or try to solve the global cooling challenge. Okay, how to counter the climate threat from room air conditioners, okay, which is very promising by its title, okay. However, the bottom line is these were the winners, and they're, with the exception of the university at the bottom, they're all major air conditioning manufacturers. And now that makes sense that they would be, you know, they have a self-interest, but their approach inevitably is and was through air conditioning. The assumption is, well, you know, we're going to have air conditioning, we're just going to have much more efficient air conditioning. So the 5x generation of air conditioners is going to be much more efficient, which is great, but it is not going to solve the problem. So in other words, you know, the title of solving the air conditioning problem, you know, kind of flatters to deceive, in the sense of their solution is more air conditioning, but more efficient, which is not going to solve the kind of problem that air conditioning is contributing. So even if, for example, at the bottom line, the 5x scenario were completely implemented, which is doubtful, the number of the CO2 emissions are still going to triple from current rates, okay, even if it all went exactly to plan, right, and everybody started using the most efficient forms of air conditioning, okay. So even the brightest scenario based on a new, more efficient generation of air conditioners is still pretty depressing. You know, 3 times the CO2 emissions by the middle of the century. And if you fall short, and we're likely to fall short from that, look where the CO2 emissions go. So there are, happily, some simple alternatives to cooling indoor spaces with expensive electrical devices, i.e. air conditioning, that make people sick, keep them poor, and heat the planet. And those are the 3 strikes against air conditioning. So daylighting, and many of these will be very familiar to anyone who's been involved in architecture, but I think worth revisiting. This is a parking structure in downtown Honolulu that I photographed last year, long before I had any interest in AC, but I was appalled by the fact that, well, look at the weather, and then look at the electrical lights inside. And of course, people occupy that space for minutes during the day, right? Nobody hangs out in a parking structure. It's just the cars, and the cars don't care whether they're in the dark. But I'm going to assume, and I don't think it's a wild guess, that this situation is repeated worldwide, where you've got electrical lighting on all day in bright sunny conditions, and there's no excuse for that. That they should at the very least be on timers, but if the building were better designed, you wouldn't need electrical lighting during the daytime at all, and that's perfectly possible. Okay, I don't see any. There are electrical lights, obviously, when it's dark, but during daylight, it ought to be possible to design parking structures so that they don't need electrical lighting during daylight hours. Same goes for numerous millions and millions of office spaces across the world. You will often see after hours, they leave the lights on, supposedly for the cleaning staff or for security, but that is a massive cumulative waste of energy that is also contributing to global warming, because the electrical lighting is, as I'll mention in a moment, a large contributor of cooling load. But just the fact that it's daylight outside and all the electrical lights on is bad enough. It's just poor design. And the price that we're paying is, well, the climate, the planet is paying the price for poor design, poor daylighting design. This is not a particularly deep office that you couldn't get sufficient daylight in if it was well designed. But the poor design is being made up for by technology and profligate energy use and heating the climate. So as I mentioned, in commercial office spaces, the estimate is that 40% of the cooling load is coming from electrical lighting. Okay, so leaving the lights on when you don't need light is bad enough, but it's a double whammy in the sense of it's also contributing heating, which then you have to turn up the air conditioning for, more electrical and more outputs of heat into the atmosphere. So, switching stuff out for diodes is a start, right? Or more efficient lighting systems. But the best possible solution is to have no lights at all, artificial lights during daylight hours, to have better daylighting then. And that's perfectly possible. These techniques have been around for decades and decades and decades. And yet, the word sustainability has been thrown around also for decades. And I see that situation of electrical lighting being left on during the day and overnight everywhere, including my own university, right, when there's nobody there. And it's hard to take people seriously when they bleat about sustainability, when they allow that kind of waste to go on 24/7, 365 days a year, all over the world. Okay. So first, turn the lights off. Sun shading, all right? It's not very sexy stuff, but this shading of this office then is fairly typical, right? It's shading indoors, right, inside the glazing line. And of course, the electrical lighting is on because there isn't sufficient daylight getting through. It would be far better for the occupants and for the planet if a different kind of shading was involved, right? First of all, this produces glare. It's kind of bright to look at the inside of those blinds, but there's no view, of course. That's been blotted out, and you still need the lights on. So it's kind of one of the worst environments, right? It's daylight out, but you can't see anything. And if you look up at the windows, you just get glare, and the electrical lights are on. Presumably the air conditioning is having to kick in to get rid of that excess heat. About the worst situation you could be in. Whereas there are much more effective ways of shading window apertures that don't block the view, don't create glare, okay, and can generate and can also help to project daylight back into the space. Things like light shelves, etc., which can also be shading devices. Again, I'm almost embarrassed to be talking about these devices because most architects have known about them for decades and decades and decades, and yet they're not being implemented. And that's, I think, a governmental, a sort of financial incentives issue. that we need to get serious about this. The techniques are known. They've been known for decades and decades. They're just not being implemented. So it's a question of implementation, not of knowledge. Natural ventilation. Well, this has been known about for not just decades, centuries, right? These are examples of South Asian jali. So perforated screens that allow air to pass. Okay. And a modern example, very nice example. And we all know these techniques of bringing air in, giving it away to escape, preferably high up, creating cross ventilation, stack ventilation, et cetera, but it's not being implemented. It's a question of implementation and education. In many of those office buildings with the lights on, it's not possible to open the windows because they don't want people messing up the air conditioning. And therefore, everybody suffers. It's probably not the correct settings for anyone. It's too hot for some, too cold for others. The ability to be able to control your environment locally, then task lighting, task cooling, like local microclimates, would make people a lot happier and save a lot of energy, because when you're air conditioning an entire space, many of those spaces are not being occupied. The conference room is not being occupied all the time, and not all the desks are. So localizing those things. Again, these techniques have been known for a long time, but it's time to implement them, because the cumulative effects are really beginning to build up, and building and energy consumption in building and the CO2 outputs from buildings are a significant contributor to global warming. Evaporative cooling. Well, sorry, a poor slide, but these are tatties. These are a reed mat that was traditionally used in India and in other South Asian countries. They would be soaked in water, and then that water would slowly evaporate. And as air passes through this mat, it would be cooled by several degrees. And in anything other than the most humid conditions, then you can get significant cooling out of that. Now, I've seen this online. Maybe we've all seen this online. Okay, fine, but it doesn't really solve the problem. I mean, it solves this individual's problem of, trying to keep cool when they don't have air conditioning. But, this plugging it in and running that fan, which you'd probably be running anyway, they would argue, this just makes it more effective. But the preference would be not to have to plug the fan in, of course. And there are ways of doing that. Then if you can get that natural breeze, the Venturi effect, the cross ventilation, the stack ventilation, then you don't need the electrical fan. And as long as you can cool some kind of mat or absorbent material and then draw air through it, you can get, as I said, in anything but the most humid conditions, you can get significant temperature change across that medium. So here's an example developed by, I think he was an architectural student when he developed it, but then I think the company or the firm is Ant Studio, based on terracotta, which is an unusual material, but was used traditionally as a cooling medium because it is porous. So this would be soaked in water, air would be drawn through, and you get significant cooling effect. Thermal mass. So, very simple. If you've got a solid floor, then wherever possible, it's better to expose it if you want cooling. Now, you may be in the winter, you may be covered up, but in the summer, if you expose that, it's first of all going to be much more pleasant to the touch. But also it's going to take air or take heat out of the air because of its thermal capacity. And that can be either direct concrete or quarry tiles, or even in this case, this is round earth, right, as a floor. Now, most of you are probably aware that water has 4 times the thermal heat capacity than concrete. So this is the Price Tower by Bruce Goff, Price House by Bruce Goff, and sadly no longer exists. But here's his thermal mass. Okay, a huge amount of water that is being stored internally. Now, there are ways to make that more interesting than just having sort of great big drums of water, but it does the job, right? And it 4 times more effectively than concrete. And if you do that, you can cover the walls in carpet because you've got your thermal mass exposed, right? If that's your thing. You may wonder, okay, what's up with these water coolers? Well, these are the original water coolers, terracotta again, and they didn't require any electrical cooling. The water sitting in there would slowly evaporate through the porous terracotta, and that actually cooled the water, kept the water cool. And a large number of these placed indoors can actually reduce the air temperature significantly. So I'm not suggesting you have water coolers everywhere, although it wouldn't be a bad idea. But some contemporary version of that, right, can have a significant cooling effect, right? The storage of water. So it's just like the Bruce Goff version I just showed, only the container is terracotta, it's porous, so you'd need to refill it. It will have, but it has not only the thermal mass taking heat out of the ambient air, but also there's an evaporative cooling effect. If you have enough of these, it's not just the water that remains cool, but the air around it is going to start to be cooled by these large masses of cool water. So those are some of the costs that we are paying, some known, hopefully some not so well known, for residential air conditioning and air conditioning more generally, and some very well known but under-applied techniques to avoid air conditioning, rather than just relying, which is not going to do the job, on a more efficient generation, right, of air conditioning. Otherwise, this is going to be our future, right? Locked away in an increasingly hot environment, running the AC more, paying more, and heating the climate more. Thank you for your time.